Ruby laser is pulsed laser and helium neon laser is continuous wave laser. Next is ruby laser. A ruby laser is a solid state laser that uses the synthetic ruby crystal as its laser medium. Ruby laser is the first successful laser developed by Meyman in 1960. Ruby laser is one of the few solid-state lasers that produce visible light. It emits deep red light of wavelength 694.3 nanometers. Construction of ruby laser. Mainly, ruby laser consists of three components. First is laser medium, second is pump source, and third is optical resonator. Laser medium consists of aluminum oxide with small amount of doping of chromium ions, and pump source consists of flash tubes which provides the excitation energy to laser medium, and optical resonator consists of silvered mirrors which reflects the photons in lasers. Next is working of ruby lasers. Here in diagram 8.6 a ruby laser diagram is shown. In this, a glass envelope is used to protect the inner ruby material. This material is ruby cylinder, and the one portion of it is completely silvered and other is partially silvered, and the spiral type wire is used for flash lamp, and power is given to this flash lamp, and cooling this system to minimize the excess heating system. And in case of ruby laser, the energy level diagram is shown in figure B. In this we get E0 ground state energy level, E1 is excited energy level, and E2 is also excited energy level. Now as we give a power to flash lamp, then this lamp will flashes light and ruby laser absorbs light, and this excites the electrons from energy level E0 to E2. Then electrons in excited state remains for 10⁻⁻8 seconds and loses their excess of energy by radiationless transition to a metastable state. In this metastable state, these electrons remains for 10⁻³ to 10⁻⁶ seconds. So these stay in this state for longer time as compared to E2 state. So number of electrons or number of atoms in this state increases with time. If the number of atoms in this state is higher as compared to this state, then our population inversion condition is achieved. If this condition is achieved, then the electrons or atom in this metastable state comes down to E0 level by releasing a photon of energy equal to 694.3 nanometer. Now this releases photon goes to partially silvered mirror and reflect back, and again reflect back. If this reflected electron again atoms in excited state tries to lower down this by stimulated emission. So we get now two photons. One is from backside and other is by coming atoms from higher state to lower state. So now we get two photons. These two photons now again partially silver goes to partially silver mirror and again reflect back, and this process continues. This process continuously takes place, and now two photons will produce 4 photons, then next 4 photons will produce 8 photons, and 8 photons will produce 16 photons, and 16 photons will produce 32, and next 64, and this process continuously repeated itself. And after some time the number of photons becomes very high, and these are reflected partially silver, these are goes outside from partially silvered mirror in the form of laser action. So in this way ruby laser achieves the lasing action. But in this ruby laser, this is pulsed laser, because here the source is flash lamp. Lamp is flashes for some second, then it off, so the laser is not continuous. We get lasing action in pulsed manner. So to remove this we use helium neon laser, which is continuous laser. Helium neon laser consists of helium and neon gases mixtures. This is generally 10:1 ratio, and helium neon laser operates at a wavelength of 632.8 nanometer in the red portion of the visible spectrum. Helium neon laser construction. Helium neon laser consists of 3 parts. First is gain medium, second is pump source, third is optical resonator. Gain medium is in helium neon gas is discharged glass tube with helium neon laser filled, and pump source is achieved through voltage through power supply, and optical resonators are silver mirrors. Next is working of helium neon laser. In case of helium neon laser, the helium neon gas mixture is placed in a glass tube. Then cathode and anode is connected through a DC power supply. As we apply here high power supply, approximately 10 kilovolt, then the electrons in the helium neon gas mixture are accelerated through this accelerating potential, and these strikes on helium and neon gases. These electron as strikes on helium gases and helium and neon gases energy level diagram shown in figure B. Helium from ground state energy level excited from E1 to E5 and E3 states. E3 and E5 states are higher and metastable states. Here helium with excited helium atom. The helium atom, as the atoms excited from ground state to E5 state. Now the energy, the atoms in the excited state E5 loses its energy, giving energy to neon atoms in ground state, and these neon atoms now excited to their E3 and E5 states, and these atoms in E3 and E5 states increases, and neon atoms also excited to E12, E3 and E5 by accelerating potential of electron strikes on neon gas. So this produces a population inversion. The number of atoms in excited state E5 and E3 increases than even state. At this condition, the lasing action takes place from E5 to E2 by releasing a photon of energy 632.8 microns. So helium neon laser releases photons of 632.8 microns. Now this single photons now again reflect back by partially silvered screen, and again this other end, this is also reflected, and this reflected photons again lower down the atoms from higher energy state to lower energy state and becomes 2 photons. These 2 photons now again reflect back from partially silvered surface and again strikes in the system helium neon gas mixture, which is shown energy level diagram, and these 2 photons now generates next 4 photons, and these 4 photons generates 6 photons. Similarly, 6 photons, these 4 photons generates 8 photons, and 8 photons generates 16, and 16 generates 32, and similarly so on. And when these number of photons becomes very high, these starts going outside from the half silvered mirror face and becomes laser output. In this process, the laser output is continuous. So this is a continuous type laser. The main disadvantage of this laser is high voltage is required, and with the passage of time, this helium neon gas mixture becomes inefficient. So other types of lasers are also invented. These are semiconductor laser. These are more efficient than ruby and helium neon lasers. Next is applications of lasers. There are a lot of applications of lasers. Mainly we discuss in 4 parts. Lasers in medicine. Lasers are used to destroy kidney stones. Lasers used for eye lenses, curvature corrections. The liver disease could be treated using lasers. Lasers are used to remove tumors. Next, in use of lasers in communication. Lasers can be used underwater communication, can be used in optical fibers, and lasers can be used in radars, satellites, and lasers in industries. These can be used automotive industry, lasers building, and lasers can be used for glass and cut glass and quartz. These are also used in integrated circuits and lasers in science and technology. Lasers can be used in computers to retrieve stored information from compact disk and to discuss and to study the Brownian motion of particles. And with the help of laser, it is possible to count the number of atoms in a substance. The next topic we will discuss in next lecture. Thank you.